Mr. Chairman, honorable guests, ladies and gentlemen, it's very pleasure for me to be able to attend this meeting. Today I'm going to talk about our paper FMSM, a fuzzy multi-keyword search scheme for encrypted cloud data based on multi-chain network. We will present our work in the following 4 areas: background and motivation, our method, experiments, and conclusion. Let's kick off on background and motivation. This figure shows the workflow of traditional searchable encryption. However, is the cloud server absolutely secure and trusted? Most existing searchable encryption schemes often assume that the cloud server is honest but curious, that it will execute the programs correctly and never actively try to deviate from the predefined protocol. In fact, the cloud servers may return incomplete or mismatched search results for many reasons, e.g. exposed to accidental attacks and malicious control. And centralized cloud servers can perform trapdoor tests and ciphertext matching without restriction and too powerful to be monitored. Although a few works have been designed to address the above problems, these techniques still exist some limitations, such as detecting cheating behaviors or inefficient. In summary, cloud servers can't be considered as trusted third parties. Recently, blockchain technology has emerged and is being used in many areas. The blockchain is a bookkeeping technology that is jointly maintained by multiple parties. It empowers data secure transmission, access, and consistent storage. Every block in the blockchain is a permanent record book of transactions, and the consensus mechanism ensures the consistency of the entire blockchain network. So it has features such as decentralization, verifiability, and immutability. Based on the above features, blockchain can be used as a trusted third party to perform search work instead of cloud servers. Related works are 20 to 25. Our main contributions are the following 3. Inspired by Chat, we introduce blockchain in ciphertext search scheme to solve the trustworthiness problem of the third party, and put the search task into the blockchain to ensure the correctness of the search results. We choose Hyperledger Fabric as a platform for experiments and design a multi-chain architecture. Different chains isolate participants and data, including chain codes, which effectively protects private data and improves the efficiency of parallel processing of data and the utilization of data storage space. The mean hash algorithm is introduced to build the indexes on the basis of one scheme, reducing the dimensionality of the keyword set through the mean hash algorithm and calculating the similarity of vectors based on jagged distance, which can greatly improve the search efficiency and reduce the space overheads without affecting the search accuracy, since the keywords are processed as 0, 1 vectors. Counting bloom filters is used as an index structure. Its counts are used to indicate keyword weights. Keywords that appear more frequently in a file have higher weights in the corresponding index structure. In the returned set of the ranked results, files with higher keyword weights are ranked higher, thus more accurate results can be returned. And next, let me show you our method. FMSM consists of 4 entities: data owner, data user, cloud server, and blockchain network. The blockchain network is composed of dual chain, DU chain, search chain, gateway 1 and gateway 2. different participants in the system need to get the authorization of the corresponding chain to join the chain and complete corresponding operations. The figure illustrates the overall structure of FMSM. The algorithm design is mainly improved on the work 17 by choosing the mean hashing algorithm as well as introducing counting bloom filters as index structure. This figure shows the search process and an example diagram of index vector and query vector. Each org in the DU chain computes a partial query subvector and then gets a complete trapdoor sent to the subchain. Each org in the subchain performs a range query based on the trapdoor. In the example, the file D contains the keywords fabric blockchain, Bitcoin blockchain, and the index vector can be generated according to the above operation steps, where the weight of blockchain is 2 and the weights of other keywords are 1. When the query statement Q contains the keywords fabric blockchain and Ethereum blockchain, a query vector can be generated for it. Therefore, subchain finally calculates the inner product of the index vector and the query vector as 10. Experiments. We compared the function features of FMSM with the schemes 17, 19, 10, and 25 in the terms of multi-keyword search, fuzzy search, dynamic updates, blockchain-based, and distributed-based, as shown in the table. The file secure index generation of FMSM mainly includes keyword dimensionality reduction, keyword vectorization, CBL index vector generation, and index vector encryption. The generation of trapdoor mainly includes query keywords vectorization, CBF query vector generation, and query vector encryption. Fig 1 shows the variation of index vector generation time and query vector generation time with a number of keywords. Fig 2 shows the variation of index encryption time with file size and compares the results with nodes of the one scheme and full scheme for analysis. The dimensionality reduction for keyword set enables FMSM to remove the part of indexed keywords, which reduces the time and space cost. And the similarity calculation using jacket distance in the index generation process reduces the computation time. Therefore, for arbitrary file size, the efficiency of the index generation is better than the other two schemes. Fig 3 shows the variation of trapdoor generation time with a number of keywords and compares the results with nodes of one scheme and full scheme for analysis. Since the algorithms of index generation and trapdoor generation are similar, the efficiency of the trapdoor generation is also better than the other two schemes. Fig 4 shows the variation of search time with file size. Although the efficiency of our scheme is slightly lower than one scheme in the single-node experimental environment, but in a multi-node blockchain network, the search efficiency increases with the number of nodes. Fig 5 shows the variation of search accuracy with the number of keywords. Our scheme's accuracy is close to full scheme and better than one scheme. Based on the above experimental environment, we increase the number of organizations in the corresponding chain in this phase to test the secure index and trapdoor generation time and the search efficiency under distributed computing. We increase the number of organizations to 3 and 5 in 10, tested the variation of the secure index generation time with the file size, trapdoor generation time with the number of keywords, and the variation of the search time with the file size under different numbers of organizations, and compared them with the data obtained under single-node experiments. Experimental results show that the efficiency of each works is significantly improved in multi-node distributed computing environment. The results are shown in Fig 6, Fig 7, and Fig 8. Here we make a conclusion. In this paper, we proposed a fuzzy multi-keyword search scheme for encrypted cloud data based on multi-chain network, namely FMSM, where we introduced blockchain and designed a multi-chain network to isolate participants and data, and achieve parallel processing of data in FMSM. Min-hash algorithm is introduced to reduce the dimensionality of the keyword set, and the jacket distance is used to calculate the vector similarity. In addition, the CBF is adopted as an index structure, and the counts are indicated to the weights of the keywords. FMSM can efficiently support fuzzy multi-keyword search and dynamic updates for encrypted cloud data. Compared with existing related schemes, FMSM achieved high security, reliability, search efficiency, and accuracy. Thank you a lot for listening. If you have any questions or thoughts, please do not hesitate to let me know. Thank you.